Welcome to True Projects. In this video, we are going to explain about the project which is Synergistic Feature Engineering and Ensemble Learning for Early Chronic Disease Prediction. So before getting into the execution, first let's understand what is the project about. So what is this chronic diseases? They are nothing but they are the long-term health conditions that often develop slowly and they can last for years or even a lifetime. Unlike acute illness, which come on quickly and can be cured or treated in a short time, chronic diseases they are persistent and they often require ongoing management. Some common examples include heart disease, diabetes, cancer, and kidney disease. These conditions they can significantly impact a person's quality of life, requiring regular treatment and monitoring. And the tricky part is that many chronic diseases don't have noticeable symptoms early on, which means people might be living with them for years without knowing. So, this makes it harder to diagnose and treat them early, which is why there is such a focus on early detection and prevention in healthcare. For instance, someone might develop high blood sugar over time and not realize they are at risk for diabetes until it becomes a serious health issue. While we have advancements in the artificial intelligence and machine learning techniques, they have improved disease prediction. Traditional models they still face challenges, particularly with the feature selection part. So they face issues with the feature selection, adaptability, and interpretability. Medical data can be incredibly complex, making it harder to identify which factors are the most important for prediction. For example, when predicting heart disease, there are numerous variables like age, weight, cholesterol levels, but not all of them matters equally. Traditional models they struggle with the irrelevant data, leading to less and accurate predictions. Moreover, these models often have difficulty in adjusting to new data or explaining their predictions, which can make them less trustworthy in real world situations. That's why there is essential that is why it's essential to use advanced methods that intelligently select relevant features and optimize the model performance. This approach can enhance the accuracy of chronic disease predictions and ultimately improve care for individuals at risk. So, to tackle all the challenges in predicting chronic disease, here we have developed the system using advanced machine learning techniques. So, by using advanced machine learning algorithms, we will be predicting chronic diseases. So, here first we begin with the feature engineering, that is, selecting the important features using the recursive feature elimination along with the support vector machine. So, in combination with the support vector machine of recursive feature elimination, we will be selecting the important features. This helps us shift through the large medical datasets to find the most relevant features which are crucial for making accurate predictions. Once we have optimized the dataset, then we feed it to the XGBoost classifier. And there we apply the Bayesian optimization technique. So what we do is first we feed feed the extracted features to the XGBoost dataset. So this classifier is really effective for spotting complex patterns within the data, which is essential when dealing with the diseases like heart attacks, diabetes, breast cancer, and kidney disease. To make the predictions more better, we are applying the Bayesian optimization technique to this algorithm. This technique it will help us fine tune the model's hyperparameters, ensuring that we get the most accurate, reliable results. Overall, this approach creates a solid foundation for effectively predicting chronic diseases and improving patient outcome. And as an extension of this project, here we are employing advanced ensemble methods. So here we are incorporating advanced ensemble methods that combines predictions from the multiple models to enhance the accuracy and also the reliability. So here specifically we are employing voting classifier which is an ensemble method. So here in this voting classifier we are combining AdaBoost decision tree and extract tree. This combination has led to the highest accuracy rates across all the data sets we tested. On top of that, we have built front end using Flask framework. So, this facilitates user testing and includes user authentication features to ensure secure access and functionality. Overall, these additions not only improve the robustness of our predictions but also make the system accessible and safe for the users. Moving on, These are the following steps used to implement the project. Let's understand them. So first, we have imported the required packages. After importing the required packages, then we explore all the data sets that we are going to predict. That is all the DCs we will be predicting. So we'll be having all those data sets, and that from that we'll be understanding the structure and the content of the data set. After exploring, then we do required pre-processing for all the data sets, and then we visualize using correlation matrix and sample outcome. And then we append features to X variable and target to Y variable. Then we select important features using recursive feature elimination, which is combined with the support vector machine. And then we split the data into train and test sets. Train is used for training the models and test is used for evaluating the models. Then we build the models. After building the algorithms, then we fit it with the data set. Then we evaluate them using accuracy, precision, recall, FN score, AUC, and MMC. And we compare them using the same graphs. Then we have developed the front end using Flash framework, which is integrated with the SQLite database. Then users they will be able to give the feature values in the front end, so they will be giving inputs to all the kinds of chronic diseases that we will be predicting in the project, and that given features they will be pre-processed at the backend, and that data will be fit to the train model for the prediction purpose. Then final outcome will be displayed in the front end. Moving on to the algorithms used, these are the algorithms used in the project. So we have used logistic regression, MLP, decision tree, random forest, k nearest neighbor, support vector machine, Gaussian naive bayes, XGBoost with Bayesian optimization, which is the proposed one, and the extension voting classifier. So this extension voting classifier has got the highest accuracy among all the models evaluated. So we have used this model to predict all the chronic diseases in the project. Moving on, to implement this project, we need hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open code folder. So here we have two subfolders in the code folder. So let's open the first application folder. Let's understand each file, how will they be used in the project. So coming to this models folder, in this we have algorithm information that will be loaded into the project code during runtime. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Next, we have is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And coming to the app.py file, this file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. So this is the signup.db file. This is the database file in which we'll be storing the user information. And if we get back here in this notebook folder, so these are all the data sets that we have used to predict all the types of chronic diseases. And these are the related notebook files of that. So what are these notebook files? These are the Jupyter notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in the individual cells, which makes it a popular choice for the data science. So first, let's see the data sets. So in this folder, we have the breast cancer data set. So let's open it. Here we have the data. So this is the breast cancer data that we have used in the project. So we have pre-processed this data and we saved it in this file. So we have saved it. These are the selected important features. And this is the target variable where 1 represents presence of the disease and 0 represents no disease. Now let's close this. So for this breast cancer, here we have the notebook file. So on this data set, this Jupyter Notebook file has been built. So in this, we will be training all the algorithms to predict the breast cancer disease, which is also a chronic disease. Coming to the chronic kidney, so let's open it. Let's open this data set. So these are the features of chronic kidney disease. From all these features, we will be selecting most important features using RFECVA with the SVM. So let's open this processed file in which the selected features are saved. So these are the features selected, important features selected from the dataset which I have shown you before. So on this data set, we'll be building the models. So let's close this, get back. So for this chronic kidney data set, we have this Jupyter source file in which we have trained all the algorithms to predict the chronic kidney data set on the chronic kidney disease. Similarly, we have for diabetes risk data set, we have heart disease data set, we have another type of heart disease, and here we have kidney disease, Pima Indians diabetes data set, and here we have Wisconsin breast cancer data set. For all these data sets, we have their individual Jupyter notebook files where we have trained all the algorithms to the respective diseases to be predicted. So this is about the data set and the code which backend code which we have built for those predictions. So get back, let's execute. So open the application, copy the path of the code folder from the address bar of the file explorer. So let's copy the path. Now open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and now click on enter. If you observe, current directory is changed to the code folder's path. So now we have to compile app.py file. So give the command python space app.py and now click on enter. So this command, it will execute Python script and execute the script and check for the syntax errors and logical issues. So after running the app.py file, it will host the application at the local address, which is the host and the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome. So I will paste it in that. Paste the link here at the end, click on enter. This is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So first let's register. So click on register. Here we need to fill in all the registration details if we are registering newly. I have already registered, so I'll directly sign in. Click on login. Give your username and the password. So I'm giving my username and the password. Click on login. We have logged in successfully and we are redirected to prediction page. Now we'll be doing prediction for all the 8 types of predictions. So 8 types of diseases. So first let's do breast cancer disease prediction. So click on that. Here you can see the parameters, right? We need to give input to all these parameters to get the prediction. That is to predict the breast cancer. So first let's understand all these parameters. So the first parameter which we have is radius mean. It is the average distance from the center of the tumor to its outer edge, reflecting the size of the tumor. Coming to the next one, it is smoothness mean. It is the average smoothness of the tumor surface, indicating how regular or irregular the contour is. The next one is compactness mean. It is the average ratio of the tumor's area to its perimeter, assessing how tightly packed the tumor is. The next one is concavity mean. It is the average degree of inward curvature of the tumor surface, which can suggest irregular growth patterns. Coming to concave point mean, it is the average number of concave points on the tumor's boundary, which may indicate irregularities in the shape. Coming to the symmetry mean, it is the average symmetry of the tumor, assessing how evenly shaped it is compared to its center. The next one is texture SE. It is the standard error of the tumor's texture, measuring variations in the pixel intensity and contributing to the assessment of its complexity. The next one we have is radius worst. It is the maximum radius measurement across different sections of the tumor, providing insights into the largest dimension. Coming to smoothness worst, it is the worst, that is highest measurement of the surface smoothness, indicating the most irregular contour observed in the tumor. Next one we have is compactness worst. It is the maximum compactness ratio found, reflecting the tumor's densest area. Coming to concavity worst, it is the highest level of the concavity observed in the tumor, which can suggest aggressive growth patterns. Next we have is concave point worst. It is the maximum number of concave points found on the tumor's boundary, indicating the greatest irregularity. The next one we have is symmetry worst. It is the worst symmetry measurement for the tumor, highlighting the most asymmetrical aspect observed. So now let's give inputs to all these parameters. So those we have in the sample file in the code folder, let's open that. Open the sample folder, sample file. So here we have predictions for all the predictions. I mean, here we have the test cases to give as the input in the front end. So we'll be using all these test cases to predict the breast cancer. So let's enter the parameters. So first we need to give the radius mean. So let's try with the first test case. So this is the first test case. Copy the radius mean and paste it here. That is 12.47. Smoothness mean is 0.996. Compactness mean is 0.1058. Next, concavity mean. Copy it. It is 0.008. Next one is concave points mean. Symmetry mean. Texture SC. That is texture error. Radius mean. We have is radius mean worst. So it is 14.97. Next one is smoothness worst. Compactness worst. Concavity worst. Concave worst. That is concave points worst. Symmetry worst. So we have given all the inputs, the parameters. Now click on predict. So the given input will be pre-processed at the backend and then we'll be getting the prediction. So here we got the prediction as breast cancer type is benign, which means the person has no breast cancer. Now let's try with the other test case. So let's try with the fourth test case. Click on prediction and that too we are doing breast cancer prediction. So click on that again. So let's copy the radius mean, smoothness mean, compactness mean, concavity mean, concave points mean, symmetry mean, texture SE, radius worst, smoothness worst, compactness worst, concavity worst, concave worst, symmetry worst. So we have given all the inputs. Now let's click on predict. So here we got the prediction that breast cancer type is malignant, which means the person has the tumor cells related to the breast cancer. So here it has been predicted as malignant. So the person is suffering with the breast cancer disease. Now let's try with the other prediction. So now let's do the chronic kidney disease prediction. So click on that. Here you can see the parameters, right? Similar to breast cancer, we need to enter all these parameters. Then we'll be getting the prediction. So let's understand these parameters first. So the first parameter is sex, which is nothing but the gender. And the next one we have is diabetes history. So it is whether the person has diabetes. It is a record whether the individual has diabetes, a significant risk of factor for developing chronic kidney disease. The next one we have is CHD history. It is the coronary heart disease. It is the history of coronary heart disease, which can indicate overall cardiovascular health, and it is often associated with the kidney issues. Coming to vascular history, it is the information regarding any previous vascular disease or conditions. A vascular health is closely linked to the kidney function. Coming to smoke history, that is smoking history, it is a record of the individual smoking habit since smoking is known to worsen kidneys health and increase the disease risk. The next one we have is HDN history. It is the history of hypertension, that is high blood pressure, which is common contributor to the development and progression of chronic kidney disease. Next we have is DLD history. It is a history of dyslipidemia, which refers to the abnormal lipid levels can impact cardiovascular health and kidney function. It is dyslipidemia. The next one we have is DM meds. It is a medication taken for diabetes management, which can affect the kidney health and help control blood sugar levels. The next one is HDN meds. It is a medication used to manage the hypertension, crucial for controlling blood pressure and protecting kidney function. The next one is ACEIARB. It indicates whether the individual is taking angiotensin converting enzyme inhibitors or angiotensin receptor blockers, which are often prescribed to protect kidney function in patients with the hypertension and diabetes. The last one is time year. It is the duration that individuals had the chronic kidney disease or related conditions, which helps assess disease progression and management needs. So we understood what are these parameters. Now let's give inputs to these parameters. So same we have in the sample file. We have test cases of chronic kidney in this sheet. So these are the test cases using which we'll be doing the prediction. So let's try with the first test case. So the gender is male. Diabetes history is zero, which means he has no diabetes. CHD history is also zero, which means person has no cardiovascular diseases. Vascular history is also zero, which means he has no vascular disease. No smoking. So coming to HDIN history, it is 1. Coming to DLD history, it is 0. DM meds is 0, which means he has not taken any diabetes related medicines. No HTN medicines. Yeah, he has taken HTN medicine, so that is why we have given 1. And the next one is ACEAIRB, it is 0. And the next one is time year is 8 years. Now let's click on predict. So here we got the prediction that chronic kidney cancer is benign, which means that person has no chronic kidney disease. But it has been predicted by the given model, that is extension voting classifier model. Now let's try using the other test case. So let's try with this second test case. Click on prediction. Again, we'll be doing for chronic kidney disease. So click on that. So here the gender is female. Diabetes history is 1, which means the person has diabetes. CHG is 0, vascular is 0, and smoking is also 0, HTIN. So let's check for the value of HTIN. It is 1. DLD is 0. Sorry, DLD is 1. And the next we have is DM meds, it is 0. HTIN meds is 1. ACIIRB is 0. And the time here is 3. So give 3. Now click on predict. So here we got the prediction that chronic kidney type is benign, which means the person has no chronic kidney disease. This has been predicted by our application. Now let's try with the other test case for the same chronic kidney. Let's try with the third test case. So the gender is male. He has diabetes. He has cardiovascular disease, coronary artery disease it is. Vascular history is 0. Smoking habit is also 0. Now let's give the HTIN. HTIN value is 1. DLD history is also 1. DM meds are 1. HTM meds are 1. ACEIRB is 1. Time year is 1. That means it took 1 year. Now let's click on predict. So here we got the prediction that chronic kidney cancer type is severe or malignant. It means that person has been predicted with the kidney cancer, that is chronic kidney cancer, and it is severe, it is suggesting. So it means that it is predicting the person has chronic kidney cancer where it has to be treated. Now let's do the prediction for diabetes. So click on diabetes risk. Let's understand all these parameters. The first parameter which we have is gender. It is the gender of the person. The next we have is polyuria. It's a condition characterized by excessive urination, often a symptom for uncontrolled diabetes due to high blood sugar levels. The next one we have is polylipidemia. It is an increased thirst that occurs as a result of dehydration from polyuria, commonly associated with the diabetes. The next one is sudden weight loss. It is a rapid loss of the weight that can occur in individuals with uncontrolled diabetes, often due to the body breaking down fat and muscle for energy when it cannot use glucose properly. The next one is gentle thrush. It is a fungal infection in the genital area that can be more complex in people with the diabetes, often due to higher sugar levels, providing an environment for yeast growth. Coming to irritability, mood changes such as irritability, which can result from the fluctuations in the blood sugar levels, impacting overall emotional well being. So, we understood all these parameters. Let's enter them. So, we have inputs in this sheet. Let's enter them. So, let's try with the first test case. So, the gender would be 1, which means he's male. Polyuria is 0. Polylipidemia is also 0. Sudden weight loss is 0. So the next one we have is gentle thrush, that is also 0. Irritability is also 0. Now click on predict. As we have given input here, we got the prediction that negative, which means patient is not having any diabetes. So he has no risk of diabetes. Let's try with the other test case. So click on prediction and again click on diabetes risk. Let's try using the fourth test case. So here the gender would be 0, which means the person is female. Polyuria is 1. Polylipidemia is 0. Sudden weight loss is 1, which means the person has sudden weight loss. Gentle thrush is 0. And the irritability is also 0. Now let's click on predict. So based on the given input here, we got the prediction that positive, which means person is risk of getting diabetes. The person is having the diabetes, so he has to be treated. Now let's do the prediction for the heart disease dataset. So click on Erbil heart disease link. And here you can see the parameters, right? We are supposed to enter these parameters. So the first parameter we have is ECG PATT. This represents a pattern of the electrocardiogram readings which reflect the electrical activity of the heart. Analyzing these patterns helps in identifying various heart conditions and also the irregularities. The next one is Q wave. This refers to the Q wave seen in the ECG waveform, which is associated with the depolarization of the ventricles. It is the presence and depth and duration of the Q waves can provide insights into the past heart attacks or my, myocardial damage, making it a crucial indicator in the heart disease assessment. So now let's give the input. So these are the inputs that we are supposed to give. So let's try with the third test case where ECGPATT value is 3 and QAVV form is 0. Click on predict. So here we got the prediction that positive, which means patient is suffering with the heart disease and he has to be treated. Now let's try with the other test case. So click on prediction. Under prediction, click on Erbil heart disease. So let's try with the fifth test case. Give the ECG PATT value as 1 and Q wave as 0. Click on predict. And here we got the prediction that negative, which means patient is not suffering from any heart disease. Now let's do prediction for heart disease, that is with the other data set. So click on that. So these are the parameters which are supposed to be given. Let's understand what are these parameters. So the first value which we have is sex, that is nothing but the gender. The next one is CP, it is a chest pain type. This categorizes the type of chest pain experienced, which can indicate the presence of coronary artery disease or other heart conditions. The next one we have is rest BPS. It is the resting blood pressure. It is the individual's blood pressure measured at rest, which is an important indicator of cardiovascular health and that can help assess heart disease risk. Coming to FBS, FBS is the fasting blood sugar. This measures the blood sugar levels after fasting. Elevated levels may indicate diabetes, a significant risk factor for the heart disease. The next one is rest ECG. It is the resting electrocardiographic results. This assesses the heart's electrical activity while at rest, helping to identify the abnormalities that may indicate heart disease. Next, we have is Talach. It is the maximum heart rate achieved. It is the highest heart rate recorded during the exercise or stress testing. Lower levels can indicate heart problems. Next, we have is Exang. It is the exercise angina. This indicates whether the individual experiences angina, that is chest pain, during the exercise, which can signal the heart disease. Old peak, this refers to the depression in the ST segment measured during the exercise, which can suggest myocardial ischemia and the presence of heart disease. We have slope here. Slope, this describes the slope of ST segment during exercise testing, providing insights into the heart's response to exertion. So coming to CA is the number of major vessels. This indicates the number of major blood vessels colored by fluoroscopy. More affected vessels suggested as a higher risk of heart disease. The last one we have is TAL, that is thalassemia. This refers to the blood disorder that can affect oxygen transport. But in the context of heart disease, it usually pertains to a category indicating the status of heart condition. Now let's enter these values. So for that, let's open the test cases of heart disease. Let's use the first test case. So we have to give the input. So the sex value is 0, CP is 0, rest BPS is 124, FBS is 0, rest ECG is 1, Talach is 163. Exact value is 0. Old peak is 0. Slope is 0. Sorry, 2. And the next we have is CA value as 0. Tal is 2. Now click on predict. So here, based on the given information, here we got the prediction that positive. It is a positive case where the patient suffers from the heart disease. So the application, it has correctly predicted by the given input. Now let's try with the same prediction, that is with the same heart disease prediction, but with a different test case. So let's try using this fifth test case, that is this third test case. So the gender is 1, that means he is male. It is CP is 0, rest BPS is 160, FBS is 0, rest ECG is 0, Talach value is 145, exact value is 1, old peak is 0.8, and slope value is 1. Coming to CA, it is also 1, and the slope value is, Tal value is 3. Now click on predict. So based on the given input here, we got the prediction that negative, which means patient is not suffering with the heart disease. Let's now do the other prediction. So let's do the kidney disease prediction. So click on that. Here, these are the parameters which are need to be entered. So the first we have is AL, that is albumin, that is albumin. This measures the level of albumin. It is a protein in the urine. Elevated levels can indicate kidney damage or dysfunction, as healthy kidneys typically prevent significant amount of albumin from leaking it into the urine. The next one we have is SC. S is nothing but serum creatinine. So this measures the concentration of creatinine in the blood, a waste product produced by a muscle metabolism. High level of serum creatinine can indicate impaired kidney function, as healthy kidneys filter creatinine out of the bloodstream. Let's give this parameters. So this is the input. So let's try with this test case where AL value is 4 and SC value is 1. Now let's click on predict. Here we got the prediction that CKD, which means that patient is suffering with the chronic kidney disease. Let's try with the other test case. So for the same kidney prediction, so click on kidney disease. Let's try with the 12th one. So where AL value is 0 and SC value is 1. Now let's click on predict. Here we got the prediction that not CKD, which means that patient is not suffering with the any chronic kidney disease. So this is all about the kidney disease prediction. Let's do the PIMA Indians diabetes prediction. So let's click on PIMA diabetes prediction. So here we'll be doing prediction using the PIMA dataset. Let's click on PIMA diabetes. So these are the inputs to be given for the PIMA diabetes prediction. So let's understand first. So the first one we have is pregnancies. This indicates the number of times the individual has been pregnant. Pregnancy can affect insulin sensitivity and may increase the risk of developing gestational diabetes. Coming to glucose, this measures the blood glucose level, which is critical indicator of diabetes. Elevated glucose levels can indicate impaired glucose metabolism or diabetes. Coming to blood pressure, this refers to the individual's blood pressure reading. High blood pressure is often associated with the diabetes and can contribute to cardiovascular complications. Insulin. This measures the level of insulin in the blood, which helps to regulate glucose levels. Abnormal insulin levels can indicate insulin resistance or diabetes. BMI is nothing but body mass index. This is a measure of body fat based on height and weight. A higher BMI is associated with an increased risk of developing type 2 diabetes. Coming to diabetes pedigree function, this is a function that assesses the genetic risk of diabetes based on family history. A higher score indicates a greater familial predisposition to diabetes. That is, predisposition to diabetes. The last one we have is age, which is the age of individual's person. So increasing age is a significant risk factor for developing type 2 diabetes, as insulin sensitivity tends to decrease over time. So let's enter all the parameters. For that, open the test cases of PMAS diabetes. So these are the test cases to be given. So let's try with the first test case where pregnancies are 0, glucose is 127, blood pressure is 80, Insulin value is 210. BMI is 336.3. Diabetes pedigree is 0.804. Age is 23. Now let's click on predict. So here, based on the given information, here we got the prediction that negative, which means that patient is not having any diabetes. Now let's try with the other test case for the same PIMA diabetes. Let's try with this test case where pregnancies are 2, glucose is 120, blood pressure is 76, insulin is 105, BMI is 39.7, diabetes pedigree function is 0.215, age is 29. So these are the parameters which are given. Now let's click on predict. So based on the given information, here we got the report that negative, which means application is predicting that patient is not suffering from any diabetes. Let's try with one more test case. We are doing for PIMA, so let's click on PIMA diabetes. Let's try with this test case where the pregnancies are 7, glucose is 181, blood pressure is 84, insulin value is 192, body mass index is 35.9, and diabetes pedigree function is 0.586. Age is 51. Click on predict. So here we got the prediction that positive, which means patient is having the diabetes disease. So now let's do with the last prediction, that is viscosum breast detection. That means that here we'll be doing breast cancer detection using the viscosum dataset. So click on that. So these are the parameters. Let's understand them. So the first one we have is clump thickness. So what is this clump thickness? This measures the thickness of the cell clumps in a tissue sample. Thicker sample, that is thicker clump, may indicate a higher likelihood of the malignancy, that is the presence of breast cancer. Coming to shape uniformity, ununiformity, this refers to the ununiformity of the cell shape within the sample. Deviations from a uniform shape can suggest abnormality, abnormal growth patterns often associated with the cancer. So coming to this marginal addition, this assesses how tightly the cell adhere to one another and their surroundings tissue. Poor addition can indicate aggressive tumor behavior. The next one is Bay nuclei. This indicates the presence of nuclei, that is a part of the cell's nucleus without surroundings nuclear material. The presence of Bay nuclei can suggest abnormal cell division and malignancy. Next one we have is bland chromatin. This refers to the appearance of chromatin, that is the material that makes up chromosomes, within the nucleus of the cells. A bland appearance suggests normal cells, while abnormal patterns may indicate cancerous changes. Next one we have is mitosis. So what is this mitosis? Mitosis, this is the count of the number of cells undergoing mitosis. This counts the number of cells undergoing mitosis, that is cell division in the sample. An increased number of mitotic figures can indicate higher rate of cell division, often associated with the cancerous growth. So this is the explanation of breast cancer parameters prediction. So let's give them inputs. For that, open the Wisconsin breast cancer parameters. Let's try with the first test case where clump thickness is 1, shape uniformity is 1, marginal addition is 1, Bay nuclei is also 1, and the next we have is bland chromatin, it is 2, mitosis is 1. Click on predict. So here we got the prediction that breast cancer type is benign. So here breast cancer, it means that person has no breast cancer. Benign is nothing but person don't have that disease. So let's try with the other test case. Click on Wisconsin breast cancer. So let's try with this test case where the clump thickness is 5, shape uniformity is 6, marginal addition is 1, pay nuclei is 4, bland chromatin is 4 and mitosis is 10. Now let's click on predict. So based on the given input, here we got the prediction that breast cancer type is malignant, which means person has breast cancer and that will spread. So let's try with the one more test case. Let's try with this test case where clump thickness is 5, shape uniformity is 4, marginal addition is 1, bay nuclei is also 1, and bland chromatin is 3, mitosis is 1. Let's click on predict. So here we got the prediction that breast cancer type is benign, which means person has no breast cancer. So in this way, by giving the parameters for respective diseases, we will be getting the predictions. Now let's check with the graphs. So here we have graphs for all the diseases, I mean for all the models built on each disease. So let's check with the breast cancer disease. Click on that. So the first graph which we have for the breast cancer prediction is sample outcome graph, which shows the distribution of the classes in the data. So here on the x-axis we have classes and on y-axis we have the count. Here M refers to the count of malignant cases and B refers to the benign cases. So if we observe, malignant count is less than the benign. M is nothing but person has the breast cancer. So this refers to the count of persons having the breast cancer, and this bar graph represents the presence of the absence of the breast cancer disease. Moving on, this is the correlation matrix which shows the correlation between the variables. So this is the accuracy comparison graph where on x-axis we have accuracy score and on y-axis we have all the algorithm names. So here if you observe, extension model is having the highest accuracy than any other models. So similarly here we have precision, recall, FN score, AUC, MCC. So these are the error metrics used to evaluate all the models built in the project. Let's check with the chronic kidney prediction graphs. So click on that. So here we have sample outcome graph where on x-axis we have the cases, that is test cases, classes, and on y-axis we have count. Here 0 represents to the absence of disease and 1 represents to the presence of disease. If you observe, presence of disease is less than the absence of disease, which means there is class imbalance in it. So here this is the correlation matrix. Here we have accuracy, precision, recall, FN score, AUC, and MCC. So similarly, we have in diabetes risk data set, herbal heart disease prediction, kidney disease prediction, PIMA diabetes prediction, Wisconsin breast cancer prediction. So among all the predictions, we observe that extension model is having the highest accuracy score than any other models. So now let's click on logout. In this way, by using machine learning models, we can accurately predict the diseases that may be multiple chronic diseases. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.